Bismillahirrahmanirrahim. Assalamu alaikum students. This is your 5th lecture of physics for 10th class. This is your new chapter sound, that is your unit number 11. In this lecture we are going to discuss the definition of sound, how it is produced by vibrating bodies. Sound waves need a material medium for their propagation and nature of sound waves. Now first of all we are going to discuss sound. What actually is sound? Sound is produced by vibrating bodies. Due to vibration of the bodies, the air around them also vibrates, and the air vibration produces sensation of sound in our ear. As you can clearly see in the picture that when the guitar strings are going to be disturbed, a sound wave is produced. That sound wave reaches to our ear, and through our ear reach to the brain, and we can hear the sound. Now there are other examples of sound. As you can see in the animation, that when we beat the drum with a stick, the membrane of the drum starts to vibrate and sound vibrations are produced. Other than this example, we have more examples. Likewise, our voice results from the vibration of our vocal cords. Human heartbeats and vibrations of the other organs like lungs also produces sound waves. Doctors use stethoscope to hear this sound. How sound is produced by vibrating body? As you can see that there is an instrument which is known as tuning fork. When this tuning fork is going to be hit by a rubber hammer, the tuning fork begins to vibrate. Its prong starts to vibrate. When its prongs start to vibrate, sound waves are produced. When the vibrating tuning fork bringing near to the ear, we can hear the sound, because the sound generated by the vibration of the prongs are very feeble. We can also feel the vibrations by slightly touching one of the prong of the vibrating tuning fork with a plastic ball suspended from a thread. As we bring that vibrating tuning fork near to the plastic ball, it will move from its mean position. Now the question arises, why the ball moves from its mean position? When we touch the ball gently with the vibrating tuning fork, the tuning fork pushes the ball because of its vibration. Also, we have another very interesting example, that when we bring a vibrating tuning fork near to the surface of the water, water splash. Why do water splash? Because tuning fork transfer its vibration to the water particles, so that is why they splash. So above these examples shows that sound is produced by vibrating bodies. Now sound require material medium for its propagation. For this we are going to do a simple experiment. We are going to use an electric bell which is suspended in the bell jar with the help of two wires, as you can see in the figure, connected to a power supply. By setting on the power supply, the electric bell will begin to ring. We can hear the sound of the bell. Now start pumping out with the help of a vacuum pump, pumping out the air from the jar. The sound of the bell starts to reduce and it will be feeble. And there is a point that when we can see that the bell is ringing, but we are not going to hear any sound, because there is no medium for the traveling of the sound. So now you have to open the tap, allow the air to enter inside the bell jar. Once again, as the air enters inside the bell jar, we can slowly hear the sound, and there is a time when you can hear the loud sound of the bell. This shows that sound need a material medium for its propagation. Without medium, sound cannot travel. Now we are going to discuss a very important topic, that is the longitudinal nature of the sound wave. As I have already told you that sound waves has the longitudinal nature, or longitudinal have two examples, that is the slanky spring and the sound waves. So in order to understand the longitudinal nature of the sound wave, once again we are going to discuss with the help of a tuning fork. As you can see in the diagram that we have a tuning fork in figure A. At this position, tuning fork is not vibrating, it is still, and you can see that on the right hand side of the tuning fork you can see the even columns of the air, or you may say a uniformity in the air column. There is a density of air molecules on the right side is uniform. So now if we are going to hit the prong of the tuning fork with a rubber pad, what happens? The prong starts to vibrate about its mean position. That is, it starts to vibrate to and fro about its mean position. When the prong moves from its mean position O towards its mean position, towards the extreme position B, it will compress the air. When it exerts some pressure on the adjacent layer of the air molecules, it produces a compression here. And when this prong will move away from point B to O and then towards the other extreme position A, it will give a space here which is known as rarefaction. So as long as the tuning forks vibrate about its mean position, it will give you a series of compressions and rarefactions. So this shows the longitudinal nature of the sound wave. Also, you can see in the animation very clearly that the tuning fork moves back and forth rapidly, and a series of compressions and rarefactions are created in the air, and you have this, in this way the sound waves propagates through the air. As the direction of the propagation of the sound wave is along the direction of oscillation of the air molecules, so this shows the longitudinal nature of the sound wave. And we know the wavelength. How would we define the wavelength of the longitudinal wave? The distance between two consecutive compressions or rarefaction is the wavelength of the sound waves, or you may say the longitudinal waves. Now by the end of my lecture, I am going to give you some questions for your practice. Likewise, what is the necessary condition for the production of sound? How can you prove the mechanical nature of the sound by a simple experiment? What do you understand by the longitudinal wave? Describe the longitudinal nature of the sound wave. Sound is a form of wave. List at least 3 reasons to support the idea that sound is a wave. I hope you will enjoy this lecture. Inshallah, we will meet in the next lecture. Until then, Allah Hafiz.